Ladies and gentlemen, welcome to the video presentation for the What's That application. My name is Conrad Schaller, and I will be walking you through this application today. Alright, so these are the three classes up here that are the main classes in this application. So if we go to Java, com.what'sthat, you know, we've got the capture image activity under UI, image under data transfer object, and DAO for the service is the image DAO class. Okay, so the image.java class here, of course, is just a custom image class that we created to have an array list that is a string array list, set a file path, and a bitmap set to be the attributes of an image object. And then, of course, the getters and setters that are associated with that. Then we have the business layer, which is actually where the API logic is all housed. So as you can see here, we have a bunch of different fields and constants set for the code here. And down here is the method that actually sends and receives the classifications. So it returns an array list called classifications. It's declared up here and manipulated down here. And basically, this method is taking an image object, the same one up here, as a parameter. And then, down here it's doing all the logic to actually send over to the API and return that list of the classifications. The API that we are using is called IBM Watson, specifically the visual recognition service within it. And what's else on here? Okay, this is just a little method that gets called down here. It kind of is just to kind of clean up and just kind of reorganize the list of classifications received back again. That's all that does. And then here is the main activity. This is where all the magic happens. Up here we have a bunch of different fields declared. We have our camera request and permission request codes to make it more human readable throughout the code. We have a string field here that's basically just going to be a placeholder for the value of the image, the entire image file path. This is basically what's going to be passed into another method, which I'll be showing to you in a moment, that will actually set the image object's file path to the string here. I have a URI, which will take the URI formatted image file path, which will allow us to get the bitmap later. I have an actual value for a bitmap here. This is what we will use to assign the image view that I have on the application to whatever this bitmap is. And then I have an image and image DAO object declared down here to be manipulated throughout the code and keep the scope as being basically contained in the entire class, not just any single method. Okay, down here I have two methods that are just to basically clean up the UI. This is to set them invisible, which I call up here in the onCreate method, and this is basically just to make the list view and the image view invisible so that the user can't see it until after the image has been taken. And of course, once after the image has been taken, that's when this set views visible gets called, and you'll be seeing that in a second. This is English. This is a method that I have created to basically set the image object, this, to set the file path and its image thumbnail. You'll see this get called later. You'll see that it returns an image and it gets passed in an image object as well as a file name, and you'll see that get passed in a moment. I have a block of code here to assign whatever the image that gets saved into. I have it set to basically use the current date and time, which was actually taught by the professor in one of their videos, so that every file name is unique and there's no overlap there. This is the actual on-click event handler for the camera. Of course, it checks to see if we have permissions to both access the camera and writing to the external storage. It then opens up the camera if we do. Otherwise, this code runs and it needs to be, the user needs to grant the permissions to open up the camera. Down here, we have the on-permission request result. This is just more processing of the request, of course. And then here's the actual open camera method. This is what's called when the permissions have been verified to be granted. It creates an intent and sets the intent to open up the camera. We have a file object called image path that gets set to the external public storage directory, which is available to all applications. I know it's not as secure, but it does make the other bit of the code a little bit easier. We then have a file object here that we pass in as parameters the image path up here, and we call the create file name method, which again creates a unique file name based on the current date and time. I then set a URI to be to basically create a URI based off of this value. We then put extra parameters into the intent and put the URI file path as one of them. We set the flags for the intent to be given permissions. And then we have the image file path. Remember, I was talking about that just a moment ago as a field. We have that value, that field value set to whatever the pic file value is up here as a string representation. I then set the image URI field to the value of URI file path. And then, of course, it starts activity for result and passes in our intent and our camera request code. Down here, the onActivity result, this is where the actual magic happens after we take the picture and accept it. I'll get to that in just a moment. I just want to cover some other stuff first. I have a method down here to create an image thumbnail. That's actually creating an input stream, and it's being passed in the image URI, which again is set a little earlier, and that image URI will allow us to actually connect to that image, create a bitmap of that image, and set it to the image thumbnail field that I have above. And then it sets this is my image view right here, and it's setting the bitmap of that to the image thumbnail that I just received. This is basically just a bit of code that I put down just basically because I have a list view that displays all the classifications, and this method gets called basically after the background tasks, which is the actual API call gets called. So you'll see here that I have an inner class, and this is actually talked about in the professor's video on threading and asynchronous tasks. You cannot run a network call, which is what this API is, on the UI thread, so you have to do that in the background, and you have to create an inner class that extends async task in order to do that. So this is the do in background method here. It's receiving an image or possibly images, in my case only one image. And then basically this is going to be a little bit confusing, but I'll walk you through it as best as I can. It takes the image object that I had created, and then it sets the classifications. And remember, the setClassifications method takes an array list as a strings. And if we look here, what is that parameter? It is image.DAO.classifyImage, and the parameter passed into that is fillImageObject, and then I have an image object and then an image file path. So fillImageObject is taking in the image object that I created as a field. It is then passing in the image file path field that I set as a string on the open camera method, and then it returns an object. This whole method returns an object. which is why it's able to work with image.dao.classifyImage, because if we go back up to that, that takes an image. And then it returns classifications, which, as we know, is an array list string. So, assuming that that is able to classify the image, it works, and we are able to pass it in there. Okay, so that's how that all works. And then, of course, it sets image classifications. This is another array list that I set as a field just to like make sure that it saves. And on post execute, so after the API call is made, I just basically call this method to set the list view to whatever those values are. Very, a little confusing, but fairly simple once you get down into it. And then the onActivity result, this is where the actual result happens after the image is taken. As long as everything's okay, we make a toast and tell the user that the image has been saved. We actually execute on the classify image task here, the actual do in background. I know it doesn't say do in background, but this, when you call .execute, it runs the do in background method down here. We set the views to visible, and then we create the image thumbnail and set that to whatever the image view value. All right, so let's see how that looks when you actually run it. And by the way, if you see here, I changed the Android manifest. I just got rid of these permissions, saved it, and added it back in so that at runtime, it should actually let us see the permissions being asked for, hopefully. Okay, it's running tasks. Okay, it should open up in a second. Okay, what's that? Find out with your camera. Let's open it up. Okay, allow what's that to take pictures and record video. Deny. Deny. Okay, unable to open camera. Permission denied. We'll try it again. Allow. Allow. And look at that. It opens up the camera. Give me just a moment. All right, once you have an image that you would like to accept, go ahead and click that. Image saved to phone. And it gives you a list view of the most accurate classifications that it can. I don't know what this word means, but I am made of skin, that is, and I am a person. And I'm assuming that this is because of the background color. We were not able to train the API. Sadly, it makes it better if you're able to train it. It makes it more accurate, along with having better lighting. And, oh, give me just a second. Apologies for that. Anyway, you have to kind of train it or have a really good camera for it to be more accurate. I mean, I'm using a laptop camera, and the lighting in here isn't exactly the greatest, especially because of that reflective background. So it can affect the results, but as you can see, it did return some accurate results. I mean, this doesn't really make any sense. I don't really know what that means. And then alabaster color, again, I'm assuming it's because of the reflection from back here, but it does return person and skin, so it does work. It's just, since it's an untrained version of the service, it basically is not going to be quite as accurate as if we fed it thousands of pictures to actually, train it and make it more accurate. Oh, and by the way, just to show you the persistence here, I'm going to go ahead and open up the files, and I will show you that the images have actually been saved. Okay, I'm going to click on that, pictures, and okay, these are all the test images I took forever ago. And as you can see right here, this is the image I just took. So it does save properly to the phone, and it does function and classify images. Thank you very much for watching. You all have a great rest of your day.